Hello friends, welcome to another video. So in the previous video we saw what should be the RPM value for second needle, minute needle and hour needle, which is 1 RPM 1 by 60 and 1 by 60 into 12. Now in this video we are going to see the basic of gear, how gear works, and then how to achieve this speed, this RPM, 1 RPM and other RPMs. So let's start. So first of all we will be looking for how gear works. Okay, so let's understand the Blix gear. So Blix has these two kind of gear in their ecosystem. The blue gear is 20 teeth and the yellow gear is 60 teeth. So now the question is, how many times I have to rotate the blue gear in order to rotate the yellow gear fully? As you can see, this is a small gear. Small gear has small perimeter. So rotating one time will not be sufficient, right? So you see, I rotate one time, it just connected, touched this black colored block. So now again I'm doing one more time, it's touching the next black colored dot, and then finally back to the origin. So that means I have to rotate this blue gear 3 times to get the other gear, the yellow gear, rotating one time. So the gear ratio is 3:1. And how fast? So I am rotating this one faster, which translates to a slower gear rotation for the yellow gear. So that means this yellow gear which is having 60 teeth, if I am applying the force on the driving gear and I am rotating the driving gear, then if the other gear which is connected to this is having more teeth than the driving gear, then the resultant value will be slower. So the connected gear will rotate slowly. How slow is 20 by 60 equal to 3. So it is 3 times slower. So that's what we saw. We rotated 3 times, then only it rotated only one time. So it is 3 times slower. So why we should slow down a gear? What is the advantage we get by that? So when we slow down the gear, we actually get a force advantage. The force is the angular force, is called torque. So we get a torque advantage. So imagine if I hang this like this and then try to hang something through this and see how much weight this gear can take. That will be 3 times less than this gear. So this, suppose if this gear can maximum take 1 kilo load, this gear is going to take 3 kilo load. That means this is getting 3 times slower but 3 times more powerful. And I can share you a video from Blix CEO. He has attempted one shot like that, where he has moved his car using the Blix gear. The car, you can imagine that the real car, how heavy it is, and he has moved it. So okay, coming back to the point. So this way we can get. So we are not looking for the torque advantage in the case of clock. We are just looking for that speed advantage. So we want to reduce the speed. So that means we have to drive this gear, because if you do the other way, if you are rotating this gear, see, if this gear I rotates only one time, starting from here, okay, see, the other gear is rotating so fast. And how fast it is? Exactly 3 times faster. In that case it will be 60 by 20. It will be 60 by 20 and the 3 will be in the numerator. So it will be 3 times faster. Instead of previously it was 1/3, now it is 3 times. So that's the advantage. So we are getting it faster, but we don't want it to be faster in our clock case. We want to slow it down because our motor RPM is already very fast. So okay, given that, let's try to understand how fast it is, and that is bringing us to the next part of the video, how to achieve the gear ratio. So we have 60 RPM gear and we want to bring it down to 1 RPM. That means we need to slow this down to 60 times. Now what can we do? Can we directly add a huge gear, or say we have this blue gear, right? We have this blue gear of 20 teeth. So can we do this way? Just the 20 teeth gear, if we connect with a gear which is 60 times bigger, means 20 into 60, 1200, 1200 teeth gear. If we connect, then we can achieve it, right? We can straight away achieve 1 RPM. Why we should not do that way? Because of the mechanical difficulty. Design a huge gear like that, it will not give you space advantage. So if you have a huge gear, you have to fit it into a smaller box. You cannot do that, and finally your end product will be a huge clock. Maybe the clock you have seen in some big busy rail station that could probably hold this kind of big gears. But I am talking about a small gear train that can do this thing. So for that we have to break it down into multiple pieces. We should not try to get it by a single gear. So what we can do, 60 by 60, right? So this 60 we can break further into some pieces. So let's try to break it into pieces. So 60 means, how can we write? 30 cross 2, right? But I would do 20 cross 3. 20 cross 3. Why? Because 3 times, right? This 3 times mechanical gear ratio. The 3 times gear ratio we have already achieved by 20:60 Blix gear that we just now saw. So this one already giving us 3 times slowdown. So this one keeping in mind, we already got the 3, and then leftover is 20. So how to achieve this 20? This 20 we can break further into 4 cross 5, right? So is it achievable? So imagine we already have a 60 gear in Blix. So by printing less amount of custom gear, because we need a custom gear. We using the 20 and 60 alone we cannot achieve this. So if we want to print a custom gear, what should be the gear teeth count? So for that, 60 by 4, 15 teeth. So one of them is 15 teeth, and 60 by, so this one is addressed, and then 5, 60 by 5 means 12 teeth. That means we need 2 more gears, 15 teeth gear and 12 teeth gear. If we get these 2, then we can write this 60 by 20 into 3 as 4 into 5 into 3. So 4 cross 5 plus 3 equal to 60. So now we understood this 4 gear ratio we are going to get by 60 is to 15. So when you connect 60 and 15 gear together, we are going to get a 4 times slowdown. 60 into 60 connect with 15, and then this one will be 60 connect with 12, and this one we already have 60 connect with 20. So these are the arrangement we have to do. So how to achieve that? For that I'll just show you some sample gear animation, and finally in the next video we're going to see how we have achieved it. So this is a website. This is a website where you can see some gears are animated and you can simulate the gears. So I will give you the link in the description, but for now just concentrate on this. So whatever we learned so far, so this is a 20 RPM and having 40 teeth, I believe. So let's find out how many teeth it is. How? So you see, this is 20 RPM and 0.5 Newton meter. Newton meter is the torque. So now if I increase this up to 40, and then you see this is also getting 20 RPM. When we can get same RPM from a gear, that is when we take 2 gear of the same teeth, same diameter, and if you try to rotate, we don't get anything. We don't get we get something. Can you guess what is that? I'm not going to tell you now. Can you write it in the comment section? But other than that, you don't get any RPM increase, you don't get any torque benefit. Just one thing you get. What is that? You can write in the comment section. Okay, so that's what is happening here. You can understand from here also what's that difference between these 2 gears. But these 2 are 20 RPM. That means this one is also 40 teeth gear. Now if I connect a 10 teeth gear, so 40 and 10, so this is the bigger gear being rotated by the driving force, right, the driving gear. So that means if I connect this, it is going to rotate 4 times faster, because 40 by 10 equal to 4, so 4 times. So 20 rpm will become 20 into 4, 80 times, so it is going to be 80 rpm. And similarly the 0.5 newton meter will reduce, because when you get a speed advantage you lose the torque advantage. 0.5 newton meter, 0.5 divided by how much advantage you got, 4 times divided by 4, so it will be, if the gear is multiplied then the torque will be divided, so you get 1.125 or approximated to 0.13 newton meter. Okay, so I'm not going into the details what is this newton meter means and all. You can find it out in the internet. I'm not spending time on that, but you get the point, right? So you are getting, and we are not looking for the newton meter now, we are just looking for the rpm. So you are increasing the we are increasing the rpm here, but here I don't want to increase the rpm. What I want to do is I want to reduce. So this, suppose this is 20 rpm, right? I want to somehow make it 60 rpm. How can I do that? So if I make it smaller, see, it is rotating more faster. And then if I make it 10, it is 80 rpm, but I want to make it 60 rpm, almost close to 60 rpm. I will keep it 57. Okay, so let it be 57 rpm, almost close to 60 rpm. And now if I connect, I want to slow down, that means I want to connect a bigger diameter. So this one I will try to make as big as possible, and see, it's 20 rpm. And then further I want to connect one more, both are same, I cannot get it by that. So see, how can you reduce further? If you have 40 rpm already connected and you want to slow it down, you want to have 60 rpm, 80 rpm, I mean 40 teeth, so you have to make it 60 teeth or 80 teeth. That is difficult to achieve, right? So what we can do is we can do this kind of arrangement. Sorry, not this one, this one. Now you see, this is 40 rpm, and on the top if you connect, you get a 10 rpm. So basically what's happening, same example here. Okay, to slow down further, what you have to do is, suppose for example we don't have a any other gear here, 15 or 12 that we calculated. So what we can do here is, this gear, right, this gear is already rotating slower. Now we want to make it 1/3 more slower. How can we do that? So for that we cannot go horizontally, we have to go vertically. So we have to put one more gear vertically on this, and in the second layer, in the second floor, what we are going to do is we are going to connect one more gear like this. So now when you have finally calculated this to this, suppose this is 1 rpm or say 60 rpm, and then this is running in 3 times slower, means 20 rpm. Now this 20 rpm gear, and this is also running in 20 rpm, because they both are connected by the axis, not by the gear. So this is also 20 rpm. Now forget about this and just concentrate on this gear. And now if you connect to the another gear, again you are getting a 1/3 reduction, and this 1/3 reduction is going to make it from 20 rpm, from 20 rpm it will become 120 by 3 rpm, which is approximately 6 point something rpm. So you started with a 60 rpm motor, and then you first reduced it to 20 rpm, and then further divided by 3 you reduced to 6 point some rpm. So that is how you can continuously keep reducing by creating a gear train, and not in the same layer. You have to increase the layer one by one. It will be like a stair. It have to be like a stair to achieve that in a smaller area. So with that understanding, let's see how we can make that clock. So the clock is already ready. In the next video we are going to see how it is working. So keep this thing in mind, and if you have any question, please write down in comment section or contact me in WhatsApp. I will give my number there. Thank you. Bye.